Hi there, Bon Crowder with Math4.com here, talking about scalar ratios and scalar factors. A friend of mine on Twitter and a member of Houston Blogging Chicks has asked me why it is her son is being asked to do scalar ratios, find the scalar factor, and put it on a table. And that's kind of boring, and so why are we doing that? So that's a good question. So we're going to talk about that a little bit right now. A scalar ratio means fraction. It's just a comparison of two numbers. So a scalar ratio is comparing two numbers with another two numbers so that it scales right up. So just like you have the scale model of a toy, like a toy train, to a big train, that's a scalar ratio. So they were asked to do a table, and I can't, this is the only table that I can possibly imagine that it looks like. So you have the scalar factor and you have the number. So scalar factors along here. Now scalar factors don't always have to be whole numbers. In this case, I'm guessing they're doing it because, I mean, really, it would take you forever to do a table with all numbers. So scalar factor of 1 is 2/3. Scalar factor of 2 is 4/6, which now we need to talk about what this means. This is not 2 times 2/3. This is really 2/3 times 2/2. So that's what a scalar factor is. You're multiplying both pieces of the fraction by that number. 3 times 2/3 is 6/9. 4 times 2/3 is 8/12. 5 times 2/3 is 10/15, and 6 times 2/3 is 12/18. So, and you can go on. The idea is you look and you go, oh look, there's my 8/12. So my scalar factor is 4. Well, wouldn't it be great if you could just say 2/3 times what over what is 8/12? That number's 4, and that's not hard to do. So I think the big question is, why are we doing the table compared to that? You got me. If you want to make it a little bit more interesting and intriguing at home, though, or even in the classroom, consider what it means to be a scalar factor of anything. So, if I have a rectangle that's 2 by 3, notice still using my 2 and 3, two numbers compared to each other. I want to make it really big because I don't like little rectangles. I can make it twice as big. I can make it 4 times as big. I can make it 10 times as big. Well, then how big is a twice as big rectangle? It's 4 by 6. What about a 4 times as big rectangle? These aren't drawn to scale. 8 by 12. There it is. 10 times as big rectangle, 20 by 30. And if I wanted a triangle that was 2, 3, and say 7, and I wanted it to be a really big triangle, if I use the scale factor 4, I would get 8, 12, and 28. Or if I was given a math problem that said, what's the scale factor between these two, I could do the same thing. I'd figure out what number I can multiply all 3 of these to get this one. Create some freaky shape. Put numbers on it. Figure out if you want to scale it up. I'm going to run right off the paper here. Scale that freaky shape up. There's the word, scale. What's the scale factor? If you want to get into the kitchen, measuring cups. The fun thing about measuring cups is as you start comparing all the different pieces of the measuring cup, you start discovering really cool things. Look at the length compared with the length. Look at the diameter compared with the diameter. Look at the height compared with the height. Is this really true scale model? I'm pretty sure it's not. But you can look at it and see. And there are going to be things in your kitchen or in your house that are scale model. Now, when you get to scale model volume or area, that's where it gets really interesting. So keep your eyes peeled because something's going to be different. We'll talk a little bit more about that at some other point. Here's another one I found in my kitchen. Plates. I have the teeny weeny bread plate and I have the big old monster dinner plate. So that's another way you can talk about scale models or scale factors. So that's the scoop on scalar ratios, which are just two numbers that then scale someplace using a scalar factor. And here's the table, which kind of looks lame in my eyes. Oh yeah, one cool thing you could do is like do 4.5 in here. That might be interesting. Maybe. Use plates, use the stuff around your house, use freaky shapes. You don't have to stick with just the table. See what you can do. I'm Bon Crowder with math4.com, reminding you that math is not a 4-letter word.